Okay, let's talk about things that influence cell size. Now, some of these things are, I'm sorry, all of these things are related to how do things get in and out of a cell. So here's like your basic cell, and the point is it has contact with the outside environment. It could be a neighboring cell, but it could also just be like if you think of, say, for example, a paramecium in a little beaker of water or something like that. It would be direct contact with the outside environment. So it's kind of easiest to think of it as kind of a single cell at this point, but cells a lot of times, and what we've been talking about, are multicellular. So anyway, but the point is to get things in and out of the cell. And when you get something into a cell, you have to distribute it around in the cell. So we're going to use kind of the getting it towards the center as the furthest point that it would have to go. Now, this is not the nucleus. That's not what I'm talking about. It's just how far would it have to go to get fully distributed from the outside in all directions, and that would be the center. Okay, so one of the things that that influences is surface area to volume ratio. The surface area to volume ratio is how much outside covering does it have versus the actual stuff that has to be, or the actual area in which things have to be distributed. So let's compare two boxes, because boxes are easier to calculate surface area to volume. So this is a 2 by 2 by 2 box. If I measured surface area, it'd be 2 times 2 times 6, because there's 6 sides to the box, or 24. And the volume would be 2 times 2 times 2, or equals 8. And my surface area to volume ratio would be 3, compared to a box that is 3 by 3 by 3. In that case, the surface area is 3 times 3 times 6, or 54, and the volume would be 3 times 3 times 3, or 27. My ratio would be 2. Now, what this means is the larger I get, the less surface area per volume ratio I have. In other words, larger cells have less communication with the outside, or another way to think about it is it would be harder for a large cell to get enough things into it and distributed around it than a small cell. So small cells have an easier time with that. This also can be a useful concept in considering things like cold, for example, or heat. The more surface area to volume you have, the colder or hotter you're going to get. In other words, your contact with the outside environment would be more influenced by this versus this, okay? So that's why things like, say, for example, polar bears are super large, right? Because they, compared to a grizzly bear, which they're related to, they have much more body mass, and that is probably related to this cold factor. In other words, it's got less surface area per volume, so to speak. Another thing that influences is shape. Now, the shape of an object can influence how far it is to the center. So let's look at this a little bit closer. So if I were to take this distance, that is the distance from the outside to the furthest point, which would be the center, that would be about that far, versus over here, if I'm an oval shape, in other words, this is the same perhaps volume, and now I've just squished it down. Then what I've done is I've decreased the distance to the center. So a lot of times really large cells will be oval instead of round. So the larger you get, you can kind of change the shape of the cell to enable you to actually kind of counteract that surface area to volume problem. The other thing is some cells that are fairly large will have many inundations. In other words, this one might have had a small surface area to volume, but because of the shape, that is many in and out of the top part of the cell, I've created then a shape that allows things to get inside the cell very quickly. So stomach cells, for example, might be a shape like this. Lots of surface area for things to come in on, and it's kind of counteracting the size of the cell that it is the low kind of overall surface area to volume by its shape. And the third thing is metabolism. Metabolism just means how well or active is the cell? How well is it functioning? is it bringing a lot of things in and out, or is it just kind of hanging out and doing a minimal amount of function? An example of this is you might compare, say, for example, your skin cells, which are kind of just blocking the way of things getting in and out of your body, versus something like a brain cell. A brain cell is very active, or a liver cell, or something like that, where they are really bringing a lot of things in and out of it. These very active cells tend to be on the smaller side, or have a shape that allows them to be active.